So this week, we have a wellness day on Friday. And since we have a no class, we have no group assignment. Any questions on that? So there's no classes on Friday. This week is the 15th week, and we'll cover chapter 13. Next week is the 16th week, or the last week of classes. And so on Saturday, the 1st, I will put up take-home part of the final. And it is due Friday the 7th. So the take-home part will be up Saturday. That way you have a whole week. I cannot take any work after Friday, May 7th, because I need to grade them and turn them in on Saturday. Any questions on that? The other part of the exam is an in-class. And that is Friday. Eight to 10 a.m. Now, if you want to take it earlier, you can take it with my other class. And my other class is Wednesday. You can take it with either class. Correct. There is no classes during finals week. You only go to your exams. Also, if you have any classes on campus, sometimes the finals are in a different room. They're not always in the same room. So make sure you check with your teacher. Most of the normal classes will be in the same room, but labs or departmental tests, or if a teacher has more than one, they may want a bigger room. So double check the time, the day, and the classroom. Notice it's not during our regularly scheduled time. Most of them are not. Any questions on that? I think that was everything on there. Chapter 13. There's an outline on Blackboard, and it looks like this. So if you don't want to write um, the, these first couple tables down, that's up to you. So chapter 13 is about how good is the test. Now, first we'll learn to read a contingency table, then we'll see about the test. This is called a contingency table. It compares two different things. Like this one is comparing female and male with undergraduate and graduate. And they're just totaling them. So going across, there's 5,680 females that are undergraduates and 2,388 females that are graduates. The total females would be 8,068. Going down would be, this is the undergraduates that are female and male, and this is the total undergraduate. This would be the total graduate. Total students, when you add across and add down, you should get the same value, and this is the total number of students. Any questions on reading the table? The probability a student is an undergraduate. If we're choosing one student at random, the probability they're an undergraduate would be the number of undergraduates divided by the number of students. To divide them. Now, when you're finding your probabilities, oops, you can write them as a decimal, a percent, or a fraction. Most of the time on the test ones, we'll do a percent because we're looking for a rate. So the number of undergraduates was 10,008 divided by the total. And if we divide them, we get the 0.745, or make it a percent, 74.5%. Any questions on that? Okay. Find the probability the student is a female and write it as a percent to the 10th. Old today. So it would be the number of females divided by the number of students. Anyone want to say the percent?
Is it 60%?
Mm-hmm. And so we have the number of females, which is going across 8,068, divided by the number of students, gives us 0.6006. We make it a percent, 60.1%. Any questions on that one? The next one, it's saying the probability that students a female undergraduate. So we want both. Another way of writing it is probability female and undergraduate. So we want the probability that it's female and it's an undergraduate. Go ahead and find the percent to the 10th. Anyone?
Would it be 80%?
We want female, oh, maybe you added both ways. We want a female undergraduate. Because it's and, it has to be both. So that would only be 5,680 instead of going across for both.
Oh.
And so, yeah, and would only mean, when you go to the total, then we also included female grads and undergraduate males because we went both ways. So you only want to go with this one because they're females and undergraduates.
So we're taking the amount of female undergraduates and dividing it by the total of undergraduates?
Yep.
Oh, okay, I did that wrong. I did like the total of females divided by the total of undergraduates.
Oh, I see. Okay.
Yeah,
I wondered how you got that large, but now I see that would be about that.
yeah.
Yep. So we wanted to divide by the total. Should get 42.3%. Any questions on that part? No, when it's, notice the next one says something's given. When it's a given, then you only use that row or that column. So the probability undergraduate, given it's a female, well, we already know it's a female, so we're only using that row. So given a female, then we only use this. The probability it's an undergraduate then would be 5,680 out of the 8,068. So if you have something given, it will either break a row or a column and you only use that part. So undergraduate given female would be 5,680 over the 8,068. %70.4%. Any questions on that one? Go ahead and try the last one that's written on here. Probability of female given it's an undergraduate. Does anyone want to say the percent? Guess it.
Do we take like, do we just take like 80, or whatever, 8,068 and then divide it by 5,680?
We're female given it's an undergraduate. Because we're given it's undergraduate, we're only going to use the undergraduate column.
Oh, okay.
When you have a given part, first find out what row or column you're using. That cuts out a lot of numbers that you don't even have to think about. So we know it's given an undergraduate, so it's only these. And then the probability of a female would be the 5680 out of this total 10,008. Any questions on that? We had done an female and undergraduate. And or is different. For and, where'd it go? There it is. Female and an undergraduate. We took female undergraduates, which was the 5680, and we divided by the total. When it's an or, it's not only both, it could be an undergraduate or a graduate. So when you have an or and you're finding the probability, you can find the probability of each one separately. And then you subtract the probability of both. Because if we take the total of the females going across, and we take the total of the undergraduate, notice going across and then going down, we use this value twice. And so we have to subtract it back out. So when you go across, you're using it, and when you go down, and so you subtract the overlap. So to find female or undergraduate, we find the probability of female, which is 8,068 out of the total. Probability undergraduate, which was the 10,008 out of the 13,433, minus the overlap, which is both, so 5680. And remember, when you're adding or subtracting fractions, the denominator stays the same, and you add and subtract the top. So when you add and subtract fractions, the denominator has to be the same. You just combine the top and keep the denominator. And then we just divide those. I'm going one decimal place. Should have 92.3%. Any questions on that?
Wait, how did you end up getting a 92.3%?
So first I added across, or subtracted, combined across the top because I had the same denominator. So the 8,068 plus 10,008 minus the 5680 will give me 12,396. I divided the total and got the 9.9228, which gives me 92.3.
Oh, okay. Thank you.
Mhm. Well, depending on your calculator, you can just add these and then convert it back to a fraction. Any questions? This sheet is not on Blackboard. I found it online and I like the problems, but then there's parts that we don't use in this class. So we'll just look at the story problem and set up the contingency table. And then we'll make our own question. But they're adding different terminology that we're not using. So. The first one, a survey asked 615 students whether they had a television in their room. There were 375 boys, 298 had a television, and 240 girls, 162 did not have a television. The first thing they want us to do is set up a two-way frequency table. And that's what we were just looking at. They're also asking here for a relative frequency table, but we're just finding the probabilities. All this does is it rewrites it with the percents in there. So we're not going to worry about that part. We just want the frequency table. Now you can decide. We had two things we're talking about, boys and girls, and a television in their room and not in their room. You have to decide which one you want to go in columns and which you want in rows. I'm going to put the television in the column. So TV, yes or no. So then going down would be boys, girls. So if they have a TV, yes or no goes here, and going down is boys and girls. Now you could have went the opposite. Either way is fine. It says a survey asked 615 students whether they had a television. The total amount in the survey, 615. And that's always our corner, our total. There were 375 boys surveyed. So the boys, the total number of boys was 375. So I'll go boys in total, 375. Any questions so far? So of the 375 boys, 298 said they did have a TV. So boys having a TV was 298. Always go through the whole thing and see what values you have before you start finding values they didn't give you. Just in case you have to move something. Of the 240 girls, so the total girls was 240. 162 said they did not have a television. So of the girls, 162 did not, so that would be here. Any questions so far? Notice if we add across the bottom, these two add up to 615. Once we find these two should also add up to 615, or somewhere there's something wrong. But when we go across, we get 603, 4, 5, 6, yeah, 615. Question. How could we find this value? Boys that do not have a TV.
Do we subtract 298 from 375?
Exactly. Because these two need to add up to this one. If we subtract them, it'll give us what that value was. So 375 minus 298. 77. Any questions? Okay. Likewise, to find the girls, if we subtract these two, because they need to add to get 240, subtract it. 78. Any questions on that? Then when we add across, it gives us that end value. Then double check adding these two, make sure you get the 615. Any questions?
How'd we get to 78 again?
The 240 minus 162. Because when we add down, they have to add up to 240, so we could subtract these two.
Yep.
Any other questions on the table? Okay, so if we choose one at random, probability they have a TV in the room.
Do we take 376 and divide it by 615?
Exactly, because the number of students with a TV in the room is 376 out of the total 615, exactly. And then writing the percent, 61.1%. Any questions on that? Probability. Let's find the probability. It's a boy and a TV in the room.
Do we take 298 and divide it by 375?
Close.
Oh.
Because it's and boy and TV, it's the 298, but we weren't given that it was a boy, so it would be the total.
Oh, okay. Thank you.
Mm-hmm. To divide them. 298 divided by 615. 48.5%. So and means it was both. Find the or. Probability it's a boy or TV in room. Want the formula for this one? Probability A or B. Probability A plus probability B minus probability A and B. Okay, this would be the formula when you have an or. So A would be boy and B would be TV in room. This is just the generic formula. You think 375. Okay, for probability of A, or the probability it's a boy, would be 375 out of the total. And then the probability of B, which is TV in room, probability of a TV in the room is 376 out of the 615. Then we subtract the probability of a boy and TV in the room, which we found here was 298. It was the overlap. We're at 73.7%. So 375 was the divided by the total was the probability of a boy. Notice that because we have the same denominator, you just combine across the top and then divide by the total. Any questions on that? Let's try the given ones. Probability, girl, given, no TV. So the probability it's a girl, given there's no TV in the room. Yeah, when something's given, it will either use one row or one column. no TV in the room. No TV, would just use this column. Sorry, I don't know why I said column, it's a row. So it's a girl given there's no TV in the room. No TV in the room. This row. Girls would be this one, so 162 out of 239. .8. Girl given no TV in the room. Okay, let's try it the opposite way. Notice they are not usually the same. So no TV in the room. Given it's a girl. So this given part narrows it to a row or a column. Only use that row or column and find the probability no TV in the room. .162 out of 240. So since the given part is the girl in the room, we're only using this column. No TV would be the bottom one, 162 out of 240. .67. We'll try another problem. But is there any questions on that one? You gotta watch the wording, but once you get to it, it's not they're not that bad. Survey asked 1,162 random people at the Southern Park Mall whether they had a cell phone plan that allows 1 gigabyte a month or a plan that allows 4 gigabytes a month. So we have females and males. Oh, that's good. Okay. You could go either way. Do we want the female and male to go across or the number of gigabytes? Since we did the last one with yeah, we'll just go columns again. On a phone, so 1 gigabyte and 4 gigabytes. So you want to find the things you're talking about first. Decide where you want them. I chose males and females to be the columns and the amount of memory on the phone to go across. Or not for data use. Survey asked 1,162 random people. 1,162. That was the total people in the survey. They had a cell phone plan for 1 gigabyte or 4. Of the 541 females surveyed, so where would 541, well, you know what, you go ahead and read it and plug it in and then I'll vote. When you first read it, said there were 541 females. So if we go down the total for females, there were 541. And of those, 108 have 1 gigabyte of data per month. 108 have 1 gigabyte. Questions on that part? Right, if we subtract these two, then we have 430. Oh, that is a 3. Okay. If we take 541 minus 108, we get the 433. They also told us 196 total people said they had 1 gigabyte. So going across the 1 gigabyte, the total was 196. What could we find next? You can find everything except for this block here. So we found the total here. Remember, these two have to add up to 1162. So if we take 1162 and minus the 196, we get 966. So of the people surveyed, 966 have 4 gigabytes of memory. Now these, then, we just have to take and subtract. We'll find all of these. So 196 minus 108 is 88. 966 minus 433 is 533. So I just took these and subtracted them. Now you could subtract these two, but I added down and got 621. And then I'm going to add across to make sure I get the 1162, so I know my values all match. If we add down, we get 621. If we add these two together, we get 1162. Any questions on that? We'll do a couple probabilities. Probability, just one at random. Probability, 4 gigabytes of data. for the 4 gigabytes of data, there's 966 that have it out of 1162. On that one. What is the probability if the male and they have 1 gigabyte of memory? Oh, pretty small. Not out of the 196. You only use these side ones when you have something that's a given. So for this one then, male and 1 gigabyte is 88. That would be the male 1 gigabyte, but you want to do it out of the total. So unless it has given, you use the total. There's only one other time we won't use total, and that is when we're finding true positive rates, true negative rates, which is the next part we'll learn. So 7.6%. Let's find the same thing but with an or. Probability male or 1 gigabyte. Or is the one where you have an overlap. Probability male plus probability 1 gigabyte minus probability male and 1 gigabyte. For this one, if we find the probability of the males are 621 out of the 1162. That would be the first one, a male. Then the probability of 1 gigabyte, gigabytes is 196 out of 1162. But notice when we go across, and go down, we use this value twice. That's why we have to subtract the overlap. And 1 gigabyte. 2.7 a fraction. It was 729. Hit record. On that one. I think this one and then the given parts give the most. Right. Probability. So this one's the probability it's a male given 4 gigabytes of memory. So be careful. I want to change. I don't want to use the same. The probability of given it's 4 gigabytes of data. Remember, given, make sure you use a certain column. Go ahead and try that one. Oh, I guess it's calling. I don't know what happened. Hello? Right. I don't know. I'm in class. Hold on. She's stuck at school, and my husband probably fell asleep in my car because he worked all night. Okay, let's double check because I got 63. So given means you only use the given part, which is 4 gigabytes. Oh, I didn't find it. I was looking at this one. So 4 gigabytes is this one. And then the probability it's a male is 533 out of 9. There you go. That one's right. 533 out of 966. So female given 4 gigabytes of data. Any questions on that? All right, let's try the opposite. Probability 4 gigabytes of data given male. That what happened in my head. Make sure for the given part that you use only given the male. Then find the probability 4 gigabytes of data. 4 gigabytes. You know it's only male. 33 is a 620. Come out. Last part shows you how good a test is. When you're talking about how good the test is, they have what's called a true positive, true negative, false positive, and false negative. A person takes the test to see if he has cancer and the possible outcomes. We're talking about the positive and negative part of it. That means what the test said. So if it says positive, then the test says you have cancer, and negative says the test says you don't. The true part or the false part in front tells you if the test is right or wrong. So a true positive means test said you have cancer and it's correct, you do. That makes it a true positive. A true negative means the test says you don't have it and it's correct, you don't have it. So the positive and negative is the test, true or false is whether the test is right or wrong. So a false positive, positive means tested positive, false means it's wrong, you don't have cancer. False negative means the test said negative, you don't have cancer, but it's wrong, you do. So positive and negative is the test, true or false is whether that test is right or wrong. When you're looking at a table, as long as your test goes across, this is where each of them will be. True positive means you have cancer and the test said you did. Here, the test says you have cancer, but you don't, and it makes it a false positive. Go on for the other two. So as long as when we put our test goes across, that's where these will be at, in the same spot every time. Look at this example. A test for diagnosing depression gives these results. This would be our yes, this would be our no. So going across is our test of whether or not the test says you have depression. Going down is whether or not the subject or student has depression. So going across is the test, which means these are both positive because the test says you have depression. Here you are depressed, so this is your true positive. This one you're not, so it's your false positive. So notice the test says yes, they're both positive. One's right, one's wrong, but they're both positive. Going across here, the test said no, so they're both negatives. This one would be the false negative because you are depressed. Person is. And this would be the true negative. So notice as long as the test is going across, these will fall in the same spot. Questions on that? So the first, well, I have to do this one. So true positive is 31 people. False negative, there was 50 people. But this was just explaining where each of them went. Any questions so far? If the person is depressed, what is the probability he is diagnosed correctly? That's called a true positive. So when you're doing like the true positive rate or false negative rates, the given part is depressed or not depressed. It always goes this way as long as your test goes across. You'll always use the total below it. So the true positive rate would be, positive is here, 31 out of 81. %38. What this means is when a person goes in and they are depressed, 38% of the time the test will say they are. So of those who go in, 38% will get help. False negative rate would be 50 out of the 81. As long as your test goes across, you use the value below. False negative rate, 50. And the false positive rate. So false positive rate here, 34 out of 291. And I think that's 12%. Any questions on the rate? What do you think about the test? Look about the test. Notice if you're not depressed, wrong 12% of the time because that's your false positive. So you're not depressed, 12% of the people are going to be told they're depressed. Well, that's not too bad. And if anything, then you get some counseling for a while. They realize that you didn't need the helping. So 12% doesn't seem too bad to be wrong here. But if we look at the false negatives, the false negative rate, 62%. So that means people who are depressed who go in and they give them a test, 62% of them are going to be told they're fine, even though they're not. That's a large amount to be missing. So I think we need a new test. So usually you want to look at these two or this one to make sure there's enough. And notice the true positive was only 38% are getting help. 62% who are depressed are being sent away. So that's pretty, they need a new test or another test. Any questions on that? So it's kind of your opinion, you're explaining, but make sure you're looking at the percents because this one is pretty high that they're not helping the people who need it. So it definitely is better. Any questions on that? So we have a homework assignment, a co-rec homework assignment, and a discussion board. There's no group assignment this week. Make sure you look at the discussion board before class in case you have questions. It deals a lot with this. What I did was have you compare a strep throat test and the COVID test because it's kind of similar. You know, the COVID test has that quick test and then it has the longer test. Well, so does strep throat. Because when you have your strep throat culture, they have a test that's pretty quick, but like this, not very accurate. Well, it's more accurate than this one though. Strep throat, if you don't take antibiotics, you could die from strep. And so anything they miss in the quick test, they need to send it away for a long test. And that's why sometimes maybe these aren't as accurate as they should be. But then we have another test. So at least we get the ones quickly, as many as we can. And then we do another test to ones we miss. And so that's what your discussion board is going to be about. Is there any questions on it? I'm going to give you time then to work on your homework and your discussion board. I don't know. I got to find out what happened to it. But I covered everything I needed to cover, so we will stop there. But if you have any questions when you're working on it, let me know, and we will go over the homework and the homework, regular homework, and then there's a part of the discussion board we'll probably go over to make sure you have the tables right, if there's questions on it. But I will see you on Wednesday.
Thank you.
You're welcome. Have a nice day.
Thanks, you too.